Hello, my ninja warriors. So today's session is all about going to be level up questions for your upcoming JEE Advanced. So if you guys have already started the preparation for JEE Advanced, then this is the session for you, because now you can come and check that what is your level of JEE Advanced. And if you have not started the preparation of JEE Advanced, you are here to just see what is there, what are the types of questions which are going to come, the level of questions which are going to come in JEE Advanced. So stay right here and solve all the questions with me. Today's session is going to be focused majorly on the integration and definite integration. So we are going to continue on important things or important questions which are PYQs and some important questions for your upcoming JEE Advanced. Before I start any further, do let me know that, ma'am, yes, you're perfectly audible and visible right away. Just confirm. Okay, let me just open the chat box. Okay. Also, do like the session and share this session with your fellow JEE Advanced aspirants. So I can see Shrutika, I can see Saiko, I can see Anantha, I can see Cuberhead. Hi. Hello, how are you all? And just let me know that if you have started your preparation for JEE Advanced or not. Okay, do let me know. All clear? I can see Cuberhead has given me green signal that all clear. Do like the session, okay? Hi Adharv, how are you? And have you guys started preparing for JEE Advanced, and how are you preparing? Let me know in the chat box. Okay, so for all of those who don't know me, who are coming to this channel for the very first time just for your JEE Advanced preparation, or for all of those who are watching my session for the very first time, this is my brief introduction. You all can see that my name is Namrata and I have over more than 10 years of teaching experience in both online and offline. I have taken various JEE Advanced batches in my previous 10 years journey, and I have also taught in one of the best institutes in Kota, that is Bansals. And now yes, these are my credentials. So without wasting any time, let's start with the very first question. Okay, all right. Yes, I can see Raj Shekhar. I can see still preparing for second session. Yes, we are going to conduct more sessions for second attempt as well, so do not worry about that. And yes, Cuberhead. Okay, all right. Now let's start. Let's quickly start. The very first question you can see on your screen. Okay, so understand that JEE Advanced questions are, I agree that they are a little tough, but not that tough that you are not able to understand or crack it. Not tough enough so that you're not able to understand or crack it. Are you getting my point? So this is your question. You can see over here that if x fx plus 3f square x plus 2, okay, x fx equals to this equation, this given information is given for your function, okay, and now this huge expression they are giving, that integration of this is what we need. Understand that obviously this question looks a little on a scarier side. It feels that I don't know what is written fx, x, I don't know how to decode it. So let me tell you, by the help of this particular thing right away, you can decode this. It is not that easy. So what you're going to do is, clearly here, you are going to differentiate this equation on both the sides and eventually calculate f dash x. This is the very first step. Okay. All right. The moment you see this question, you'll be like, no, ma'am, I don't even know how to proceed. Let me tell you step by step. What is the first step? That, okay, this is something which is scary. This is something which obviously I need to decode. But to decode this, I need to take help from this equation. Okay, if I take help from this equation, then this whole integral expression will become very, very easy. Okay, are you getting my point? So one by one we are going to do. First of all, this equation is what? X. This equation is x f of x is equals to 3 f of x whole square plus 2, correct? This is your equation. Now what I'm going to do is very simple thing. Not at all a JEE Advanced thing I'm going to do over here. I am just going to differentiate this on both the sides. Let's do that. Let's help me. X, fx, obviously on the left hand side, product rule will be applicable. X, f dash x. X kept constant. Derivative of fx is f dash x plus. This time fx will be constant and derivative of x will be 1. Yes or no? So left hand side differentiated. Now this 6f of x, f dash x plus 2 is obviously 0. Okay. Clearly now what I want f dash x value. So this is f dash and this is also f dash. So fx from here will be nothing but 6f f dash minus x f dash. Yes or no? Right now I need f dash value. So f upon 6f minus x is nothing but f dash. So this is the value of f dash x. This is what I was looking for. Okay, and if you just, this is actually what? 6 f of x minus x. Everybody, did you find any difficulty in doing this thing? No, right? Now focus on this. Can you see that a similar thing I can observe? 6fx minus x. This is written right here. Okay? And what about this? X square minus fx is also here. And this is also something similar. Okay, so I can see that something similar is getting formed over here. So what I'm going to do is, I'm going to do this whole thing on the next slide. Okay, so let me just copy this expression on the next slide. Okay, this is the expression. Okay, what I'm going to do is, understand, let us resolve this a little bit. From the first two expressions which I am clearly seeing, 2x can be taken out, correct or not? If I take 2x out, what do I get? Ma'am, 2x, if you take x minus 6, x is gone, fx. Okay, plus fx was already there. Step by step, slowly, start very like beautifully and gracefully you have to solve JEE advanced level question. And this is x square minus fx. And this is whole square. This is your dx. This is your integration. Let me copy that expression. F dash x which we have calculated. F dash x is nothing but fx upon 6fx minus x. Correct or not? Okay, 6fx minus x. So now with the help of this, we are going to try and understand that, okay, so this is x minus 6fx. So rather than taking 2x common, can I take minus 2x common? Yes, definitely. If I take minus 2x common, it is going to become 6fx minus x. Okay, and understand now, 6fx minus x is what? From here, 6fx, this is fx upon f dash x, correct? Put this value right away. So this is integral minus 2x kept as it is. 6fx minus x is f upon f dash x. Okay. Now plus fx is written right here. Whole upon, you are going to have now 6fx minus x again is f upon f dash x. So this is f of x upon f dash x and this is plus f of x. Integral and this is dx. Can you see it clearly that fx is gone? Gradually, step by step. What we are doing? We are reducing the scary looking expression with the help of just this expression, right? So now if you understand, this is going to become 1. Okay, now if you take LCM, let's take LCM, right? So let's start taking LCM. This is minus 2x upon f dash x plus 1 whole upon, this is 1 by f dash plus 1. Okay, this is dx and this is integral. Correct or not? Now again, now take LCM. Now is the time that you take LCM. So minus, so this is f dash x minus 2x upon f dash x plus 1 integral, and this is with respect to dx. Correct or not? So, okay. And let me just go back and yes, did I forget that x square minus fx whole square was already written. X square minus fx whole square was already written. X square minus fx whole square was already written over here. Correct? Okay, so if I put x square minus fx, now understand, put x square minus fx equals to t. What are you going to get? X square minus fx is t. So you are going to get 2x minus f dash x dx is equals to dt. So this is going to give you minus dt vibes, minus dt upon this is f dash x, okay, and this is your t square, correct? F dash x plus 1 is already there. 6fx, okay, hold on. This is plus 1. Plus 1 is not written, yeah. 6fx minus x. 6fx minus x, sorry, this is just f dash x is missing. Huh? This is just this. That's it. आगे बढ़ते हैं. This plus 1 is gone. Plus 1 is not there. 1 by f dash x. So now if you take LCM, this expression is not available. Now it's fine. Okay. So this is what it is. Now integration of this is 1 by t plus c. What is 1 by t? So 1 upon x square minus f of x plus constant is your answer. Okay. So x square minus fx, option A. Can you see this 1 upon x square minus fx is matching with option A. So option A is correct. Have a look. Let me know. Yes, yes, yes. Boards ke liye, yes, we are going to start for boards also super soon. Getting it? Understanding it? Yes, cuber head. Okay. All right. Free pie. Little Marathi, I know, but this channel is just dedicated for English language, so I can't speak Marathi on this channel. And now, the first question done and dusted. Just tell me, how would you rate this question? Was it difficult? Was it very difficult? What do you think? I don't think this is a difficult question because see, what we did is differentiated this equation, calculated f dash x, and then eventually put the value of 6fx minus x multiple times. I can see. Just put it, solve it. The moment you solve it, you will realize that you are going to get, this is, if you put this as t, this is going to be dt. Very easy question, right? I don't think so. You can find any difficulty, any challenge in this question. Now we are going to move ahead and talk about the moderate question, okay? Yes, second question on your screen, again from the world of integration, okay? So the question says, if a function is defined in such a way, then f of 0 is 1 is given, then which of the following is correct? So basically, we have to integrate this function, eventually find the full-fledged function, and we need to comment that whether my function is an even function, onto function, odd function, many function, whatever. Basically, we have to figure out my fx, okay? If you see this question, fx is what? Now, see, f of x is integration of x power 8, okay, x power 8 plus we have 4 upon, we are going to have x power 4, then we are having minus 2x square plus 2. What I am going to do is, right away so you can't integrate, but you have to make the numerator a perfect square, okay? So what I am going to do is to make it perfect square, so this is see, x power 4 ka square, this is 2 ka square. So I am going to add 4x power 4, correct? 4x power 4 minus 4x power 4. Why, ma'am? Why are you doing this? Because you see, this part is becoming a perfect square and this is itself a perfect square. So now fx and dx was already there, right? So f of x is going to be x power 4 plus 2 ka whole square. This whole thing which you are seeing right here, don't you think this is a perfect square? This is x power 4 plus 2 whole square minus, can you see this is 2x square whole square. So now we are going to do a square minus b square in this question. A square minus b square. And in the denominator you already have this. And in the denominator you already have this. Okay, so a square minus b square. Correct? So now your fx will become what? Tell me. A square minus b square. So a plus b, x power 4 plus 2 plus 2x square. A plus b. A minus b plus 2 minus 2x square whole upon, this is x power 4 minus 2x square plus 2, and this is integral, this is dx. Are you getting my point? Are you understanding it? Okay. So now this you have to cancel it with this. Can you see that cancellation thing? Now see fx, integrating fx is going to be a cakewalk for you. Fx equals to x power 4 plus 2 plus 2x square. So fx, now I have my fx, which is equals to, by the way, x power 4 plus 2x square plus 2. Integral with respect to dx. So now integrate now. F of x will be what? X power 5 by 5 plus 2x cube by 3 plus 2x plus constant. This is your fx. As per the question, f of 0 is equals to 1. F of 0 is given as 1 as per the question. So satisfy f of 0 is equals to 1. So from here 1 equals to 0, 0, so c is coming out as 1. If you put x equals to 0, your constant term is going to be what? 1. Correct? And now, final time of writing this function, f of x equals to x power 5 by 5 plus 2x cube by 3 plus 2x plus 1. This is your function. Now tell me whether your function is an odd function or an even function or 1-1 function or many one function. These are the 4 options which are given to you, okay, for this particular question. Can anybody tell me? Okay, yes, Cuberhead, you have cracked this question. Very good. Understand, see, odd function, if you go by polynomial, term by term you can just gauge whether the function is odd or even. Understand that this term is suggesting me x power 5 that this function is an odd function. Okay, this is also an odd function term, but this is an even function term. So understand that this fx is not equals to f of minus x. Hence, this implies that not an even function. This function is not an even function. And neither your f of x is becoming minus f of minus x. Both are not getting satisfied. So, not an odd function as well. Neither even nor odd function. Neither even nor odd. Now, let's talk about 1-1 or not. Okay, whether this function is 1-1 or not. To calculate 1-1, we just need to know the derivative. If the derivative of this function is either always positive, that means this function is an increasing function, then we can say that, okay, increasing functions are always 1-1. Decreasing functions are also always 1-1. So, f dash x differentiated. So, this is x power 6. Okay, differentiate now. No, sorry, x power 4 plus x. So, 3 2s are 6. 6 by 2x square. Differentiating. So, can you see this function f dash x can never be negative. Why, ma'am? Because see, any term, every term is having even power. Even if you put any even if you put any negative number now, then also your expression will always be positive. What I am trying to say is, this is positive, this is positive, this is positive. So, 3 positive things, if you add, it can never be negative. So, this is always positive for all values of x belongs to real. That means the function is increasing function, and you know increasing functions are always 1-1 function. So, this is a 1-1 function, but not at all a many-one function. Correct answer of this particular question is, okay, this is also wrong. On 2, I don't know. Odd or wrong. Many-one is also wrong. So fx is an onto function is also is absolutely correct. Okay, onto function. Now ma'am, but onto, so you didn't judge. Understand that this function which you are getting is a power 5, that is odd polynomial. Odd polynomial. Odd polynomial. So cubic, power 5, power 7, all this type of polynomial, cubic polynomial, right? Odd power, odd degree polynomial basically. Odd degree polynomial are always onto. Basically what I'm trying to say is range of this function is nothing but all real. If range is all real, codomain is also all real, then definitely this function will be an onto function. Did you get it? How did we find that this function is onto function? Yes, free pie? Okay. Alrighty, clear? Chalo. Let us move on to the next problem. Next problem on our screen is this. Okay. Now understand, the similar type of problem was asked in JEE main as well. So this is a specific problem which we are going to deal right now. There is a specific solution of these type of problems. Okay. All right. Let us understand the specific, what is so, and this is by the way my favorite. I call it as kutur putur. Kutur putur means manipulation. Kutur putur means manipulation. Manipulation means whenever you see higher power polynomial, whenever you see higher power polynomial, understand, whenever you see higher power polynomial, then understand that, okay, kutur putur or manipulation technique is going to be applicable in this question. And you can see that power of x is 3m, 2m, m, 2m, m, x, and so on. So kutur putur technique says that you have multiple brackets, and in this kutur putur you're going to have two brackets, either both in numerator or one in numerator, one in denominator, like that. Understand that what you have to do is you have to rearrange the x, power of x, from one bracket to another bracket. Let me tell you about this technique, very good technique. So I will be like, okay, obviously this is the basic substitution question. First of all, the first thing is I need to substitute something as t. Substitute anything as t, and what will happen in the next step, something dx will become dt. Yes or no? This is what we usually do. Same thing we are going to do, but with a little twist. This we are going to do same thing, but with a little twist. Ma'am, what? Substitute something and make it equals to t. So my point is, let us substitute this as t. Okay, sorry, let us substitute this as t. Yes, this should be substituted as t because power is 1 by m. So if we substitute as t, automatically this free bracket will become this and dx will become dt. This is the most obvious thing which we can see. But right now, if you substitute this as t, you will not get dt. Then we have to adjust our x. We have to adjust the x. Okay, so what I'm going to do is, I am going to divide this expression by x. Okay, let's do that. Divide it by x. And I'm going to multiply it with x. So multiply x in this bracket. Dividing x from here, and I'm going to insert the x into the second bracket. Okay. So this is what, like here and there, kutur putur, hera feri. Do you know what is hera feri? Hera feri? Hera feri means that some x you are taking out, some x you are pushing inside, like that. So if you divide this by x, tell me, ma'am, x power 3m minus 1 and plus x power 2m minus 1 plus x power m minus 1. And it actually looks sorted. If you see, if you put this as t, na, so something minus 1 differentiation work like this, no? X power m ka derivative, x power m minus 1, like that. So it is happening. We are able to get to that. Now multiply x. Now understand there is 1 by m power. So can I do one thing? X power m into 1 by m I can do. Okay, so that now this is also 1 by m, this is also 1 by m. So x power m, if I multiply inside, this is 2x power 3m plus 3x power 2m plus 6x power m power 1 by m dx. Okay. All right. Perfect. Now this, understand this. Understand this. 2x power m, this I am going to put this as t. Okay. So put this as t. If you differentiate this, what are you going to get? Tell me, ma'am, if you differentiate this, now 3 2s are 6 x power 3m minus 1 plus 6x power 2m minus 1 plus 6x power m minus 1 dx equals to dt. Yes or no? This is, if you put this as t, then this thing is going to get. So 6 if you take common, so this is going to become what? Dt by 6. So integration, this is t power 1 by m by 6 and this is dt. Okay, so if you integrate, this is t power 1 by m plus 1 upon 1 by m plus 1 and this is your 6 plus constant. Okay, what? T power 1 by m. So now this integration is done. Evaluate for. So we are evaluating. The answer of this question will be, understand. So this is what we have gone. Okay, m is also there, correct? M is also there. Na? Power will come in front. So 6m, 6m, 6m. So this is 1 upon 6m. So this is, if you multiply m inside, t power 1 by m plus 1 upon, if you multiply this inside, this is 6 plus 6m. 6 plus 6m. So correct answer, let me tell you, 6 plus 6m. And this is t power m plus 1 by m plus constant. This is the final answer. Okay, kutur putur, getting it? Coefficient 6m. Yes. Yes, Pradeep, absolutely. Okay. All right, clear. Chalo. Let us start talking about the next question now, which is this. By the way, this question was asked in JEE 2008, JEE Advanced Question Paper 2008. I would say good question. Okay. So this question is going to talk about I is an integral, j is another integral. Now they are not asking you to calculate I and j separately. Rather, they are focusing on j minus I. Okay. So if you try to calculate j and I individually, you might fail. But if you combine j minus a nicely, then you will be like, this integration has become a cakewalk for you. Okay. So understand, this is your I, this is your j. Correct. Now, there is a difference actually. If you carefully observe I and j, na, and obviously j minus I, you have to perform the subtraction. What is going to happen is that the denominators are not the same, but the good news is you can make denominator same. How come? Just multiply e power 4x in the numerator and e power 4x in the denominator. Now just tell me, what is your j? Can I rewrite the j? So j over here will be e power 4x minus x, so e power 3x upon, if you multiply e power 4x in this bracket, so e power 4x plus e power 2x plus 1 dx. This is your j, correct or not? But I am not interested in j, just j. I am interested in j minus I. So this is your j minus this is your I. Now you have both the denominators same. Both denominators are same. Right or wrong? Both denominators are same. So e power 3x minus e power x upon e power 4x plus e power 2x plus 1 integral dx. Correct? This is your j minus I. Now what we are going to do is substitution. We are going to obviously take help of substitution. E power x I am going to put as t. So e power x dx will become what? Dt. So now this is going to become e power x if you take common. So this is e power 2x minus 1 e power x dx upon, this is what? Same, t power 4 plus t square plus 1. Correct or not? And this is what? E power x dx will become dt. And this is going to become e power 2x minus 1. So e power 2x minus 1 will be t square minus 1. Okay? Clear? This is how it is. This is the integral which we have to figure it out. Till now, any doubts, any confusion till this step? I think, yes, PYQ, this is a PYQ. Response sheet, we are expecting response sheet to be released in a day or two. Let's hope for the same. Okay. So, t square minus 1 dt upon, we are going to have t power 4 plus t square plus 1 integral. Let's integrate now. What kind of integration is this? Do you remember that type? What I'm going to do is, from numerator and denominator, I am going to take t square out, and then you will remember this is also in your NCERT, this type of integral. Take t square out. 1 minus 1 by t square dt. Correct? And if you take t square out, t square plus 1 by t square plus 1 integral. Correct? Now understand that t plus 1 by t, you have to put it as u, so that 1 minus 1 by t square will become du. So the numerator is becoming du and t plus 1 by t is becoming u. Now if I square, but I have t square plus 1 by t square. So what I'm going to do is, I'm going to square t square plus 1 by t square plus 2 is equals to u square. So t square plus 1 by t square is u square minus 2. U square minus 2 plus 1 integral. This is du upon u square minus 1 integral. Okay, so this integration of this is not very difficult, right? This is going to become half ln mod of u minus 1 upon u plus 1 plus constant of integration. And now if you put the value of u right here, what are you going to get? U, where is u? T plus 1 by t minus 1, t plus 1 by t plus 1. Okay, plus constant. Again, 1 by 2, take LCM, t square minus t plus 1 log of t square plus t plus 1 plus constant. Now t again. If you go back, there was something. T is nothing but e power x. So this is 1 by 2 log of e power 2x minus e power x plus 1 upon e power 2x plus e power x plus 1 plus constant of integration. And the numerator is negative, denominator is positive. So, sorry, option A is not correct, right? Option A has power 4. We are looking for something which has e power 2x. Option C is correct, right? Option C. So, option C from here is absolutely correct. Okay. All right. Perfect. Okay. Let us move on to the next problem from the world of integration. Yes. Okay. Next problem right here in front of your screen. Okay. JEE Advanced 2014. JEE Advanced 2014. Okay. So there is this question, if you can see, and you don't have to integrate it. You have to convert this integration. You have to understand this. 2 cosec x power 17, and the integration is starting from pi by 4 to pi by 2. Okay. So few things, few trigonometric identities will be needed to decode this question, which I am going to write right away. Okay. So just understand. 2 cosec x. What I am going to do is, this is pi by 4. Very good question, I would say that a little bit manipulation skills are required. 2 cosec x power 17, right? So 2 cosec x power 17 and this is dx. Let us write it this way. Now 2 cosec x, I am going to write 2 cosec x as cosec x plus cot x plus cosec x minus cot x. Can I write this way? Yes or no? Because anyway, so I have added 1 cot x and I have subtracted 1 cot x, correct? Now you have to understand one thing, that cosec x plus cot x is equals to 1 upon cosec x minus cot x. Basically, cosec x plus cot x and cosec x minus cot x are reciprocal of each other. So this cosec x minus cot x, this thing, the second expression, so that I am going to change now. This is pi by 4, this is pi by 2. So this is cosec x plus cot x, and now plus, this is cosec x minus cot x. Now cosec x minus cot x will be 1 upon reciprocal, right? Cosec x plus cot x. Power 17 is right there. Dx will be right here. Okay. All right. Now understand. As per the options, we can clearly see that in the bracket, see, this is in the bracket, we have e power u and e power minus u. So what we are going to do is, these options are telling me, okay, I am not doing anything. Options are clearly hinting that you should put this as e power u, because you are not calculating the value of integration. You want to convert this integration into one of these forms. So cosec x plus cot x. Now understand, cosec x plus cot x, you have to put e power u. So cosec x minus cot x, because both are reciprocal, right? This is going to become e power minus u. Correct? Now you have to obviously differentiate. If you differentiate, cosec x plus cot x is right there. If you differentiate this, you are going to get minus cosec x. You differentiate it, minus cosec x dx is equals to du. Okay? Minus cosec x dx is equals to du. All right? Yes, minus cosec x dx is equals to du. Now understand one more thing, that rather than doing this, see, I want my cosec x, correct? Rather than doing this for 17 terms, because as per the question 16, I can see 16 over here. So what I am going to do is, 17 is not required over here. What you do, see, 2 cosec x, this is 2 cosec x power 17. What I am going to do is 2 cosec x. I am keeping it 1 cosec outside, and 2 cosec x power 16 will be there. I am going to alter this 2 cosec x power 16. So this is 16, and 2 cosec x I have kept it outside, because obviously now I realized I need 1 cosec x, because I need to mark it as dx. So this both thing will become minus du after this. Okay. So this is 16 and 1 cosec x, I have taken it out. So 2 cosec x dx. Correct. Now this is your substitution, you can see. And now upper and lower limit obviously are going to change. So if you put x as pi by 4, if you put pi by 4, this is root 2 plus 1. And if you put pi by 2, 1 plus 0. So root 2 plus 1 se leke 0. Can you see? Root 2 plus 1 se leke 0. So clearly e power u is equals to root 2 plus 1. This is lower limit. So u will be equals to what? Log of 1 plus root 2 and lower limit. This is upper limit is what? 1. So this is going to give you e power u is equals to 1. So this implies u is equals to 0. This is upper limit. So upper limit will be 0 and lower limit will be log of, upper limit will be 0 and this is log of 1 plus root 2, correct? This, my dear students, is going to be e power u. This, my dear students, is going to be e power minus u. Obviously both are reciprocal of each other. So e power u plus e power minus u we have. Then 2 cosec x was already there. So minus cosec x dx, I am going to write du. So 2 du with a negative sign. This is your final integration. We have converted everything attention to detail, one by one, step by step, we have done this. Okay. All right. Okay, thank you, Cherry, thank you. Now, understand. See, negative sign you have to flip. If you have to flip negative sign, this is use the property. Okay. Interchange your upper and lower limit. This negative sign will be gone. This is e power u plus e power minus u. And this is 2 and this is du. So now this is your integral. You don't have to solve this integral. Understand? And 16 is already there. 16. Yeah, you don't have to solve it. You just have to match. Now this is the final answer. JEE Advanced 2014 question done and dusted without even any hurdle over here. So first of all, this is wrong because 17 is not what we want. We want power 16, number one thing. 2 is right there. So A and D, between A and D, can you see this plus sign and minus sign? So option A is absolutely right. D is not correct. Yes, Mohan. Yes, Mayank Singh. Are you getting it? Are you understanding it? And see, JEE Advanced may, if you are just starting it now, you might get a little frustration. Be prepared for it. That ma'am, question level is becoming difficult. I am not able to get through it. Just solve each PYQ twice. Solve each PYQ. 90% PYQ you have to solve twice. And you, then what will happen? Do not apply your brains that is it happening, is it not happening, am I able to solve, am I not able to? Do not apply brains. At least for 10 days, beginning 10 days, PYQ, start solving PYQ without applying your brains. Every PYQ twice. Okay, so after second time you will be like, now I am getting it. After 10 days you will see a change. That now I am getting that interest. This is the way. Mindset shift requires some transition phase. It can't be happening that, okay, day 0, I am done with mains. Now, day 1 onwards, I am going to crack JEE Advanced. No, it is a process. Start. It is just like your old bike. Now, what do you do when you have old bike which has not been started? So you try giving race. You just do some warm up with that bike. Engine warm up requires some time. So your brain also requires some transition phase. Okay. All right. So do not get scared if you're not able to. If you find any problem a little bit scary, then do not get scared. Now this question, I would say that this is not even a JEE Advanced level question. This is a JEE Main level question. In fact, if you observe, JEE Main 2025 gave a question like this. Yes, JEE Main gave a question like this. Not a very difficult problem. And also, this problem, I will use a shortcut. Okay, direct shortcut. Let me just tell you. This 1 plus e power sin x. So first step is I am going to apply King's property and I am going to apply King's property and add both the integrals. So what I am going to get is 2i obviously. So I will be equals to 2 upon pi. Okay, and so this is going to become 1 plus e power sin x is going to, yes, this is 2i is equals to, so 1 plus e power sin x will be gone and this is dx upon 2 minus cos 2x. Direct shortcut if I apply, you will get this. Now you will be asking, ma'am, which shortcut have you applied? I will give you the shortcut right away. So what I did is, the moment you will apply the shortcut, that is King's property. So this expression will go away. And instead of that, 1, 2 also, like the whole integral will get divided by 2. So whole integral will get divided by 2, matlab 1 by 2 you will get from here. This is the shortcut. Anybody who is not aware of the shortcut can tell me in the chat box. Okay. So tell me what will be the value. So 2 cancel. I will be equals to 1 by pi. This is minus pi by 4 to pi by 4 dx upon 2 minus cos 2x. Now understand cos 2x. Cos 2x can clearly be written down as, okay, so cos 2x, 2 minus cos 2x. Cos 2x will be 2 cos square x minus 1. Correct or not? Okay, so this is going to be 1 by pi. Okay, minus pi by 4 to pi by 4. and this is dx upon 3 minus 2 cos square x. Now understand, this is an even function. This whole thing is an even function. For an even function, now understand what property I am going to use. Minus a to a fx dx is going to be 2 times 0 to a fx dx. Okay? Can you see this? All right. So same thing, can you see even function is right there, minus pi by 4 to pi by 4. So this is going to become I 2 by pi 0 to pi by 4 dx upon 3 minus 2 cos square x. This is your integral now. This right away is your integral. JEE Advanced 2019, now so you are gone. This is very easy to solve. Integration right now is 2 upon pi integral 0 to pi by 4. Now you are having dx upon 3 minus 2 cos square x. How to integrate this? So from here we have to multiply sec square x in the numerator, sec square x in the denominator. What are you going to get after that? 2 by pi 0 to pi by 4 sec square x dx, and this is 3 times sec square x. If you multiply 3 times sec square x. Sec square x is what? 1 plus tan square x minus 2 times sec square into cos square is what? 1. So now understand that you have to put tan x equals to t. If tan x is going to be t, then obviously sec square x dx will become dt. Upper and lower limit are going to be 0 to 1. This is dt, and this is 3 minus 2, 1 plus 3t square. 1 plus 3t square. Okay. 1 plus, now direct formula will be applicable. 2 by pi, this is tan inverse root 3t upon 1, this is 1 by a, so 1 by a is this, and upon you have to differentiate root 3t, so you are going to get root 3 over here, and this is 0, this is 1. If you put 1, so 2 by pi, the moment you put 1 over here, tan inverse root 3, tan inverse root 3 is 60 degree. Okay, pi by 3, 60 degree, and tan inverse 0 is gone, so pi by 3, and this is root 3. 2 by, to pi cancel, this is 2 by 3 root 3 by 2, okay. So 2 by 3 root 3, 2 by 3 root 3. So 27, and 3 root 3 will be what? 27. So correct answer of this question will be 4. 4, 4, 4. Yes, session 2 we are going to get, okay. All right, yes, yes, yes. Okay, Santosh is asking, ma'am, how you removed that term. Okay, let me go back. I have used a shortcut. Acha, here only we have done, na? So how, ma'am, how did you remove that term? Who all want to know how did I use that shortcut? Who all want to know that I used, which shortcut I have used? Let me just give you over here. So this question was, see, the question was 1 upon 1 plus e raised to power sin x, correct? Minus pi by 4 to pi by 4, I equals 2, okay? And this is what? 2 by pi 2 minus cos 2x, correct? This was the question, correct? Now King's property I am going to apply. How to apply King's property? Your x will be replaced by King's property and then add. Your x will be replaced by minus x. X will be replaced by minus x. So I will be equals to 2 upon pi. X will be replaced by minus x. So this is your dx upon 1 plus e power minus sin x. And this will remain same because cos of minus x is not something which we need to bother. Cos minus x is cos x. Now, if you take LCM, again, same thing. If you take LCM, now what will you get? Tell me. So, ma'am, e power minus sin x will become what? 1 upon e power sin x. If you take LCM, what are you going to get, ma'am? Take LCM. So, this whole thing will become e power sin x 1 plus e power sin x. Now, what you need to do is you need to add 2i. is equals to 2 upon pi minus pi by 4 to pi by 4. Okay, if you add, you will realize that, okay, denominators are same. Cool, denominator is same. Okay, what about numerator? So numerator can be added if you add 1 and e power sin x. 1 plus e power sin x if you add dx. So these terms will get cancelled out. This is a very, very frequent thing which we have already done in JEE main as well. Similar question was asked in JEE main. Just go back. JEE main 2025. Yes, JEE main 2025. Same question, similar type of question was there. Okay. Anybody after this video, you can comment the shift also, that you have to remove this. Now understand 2 to cancel. So this term is removed. Now what has become? So I is equals to, what has I become? This, see, I is equals to 2 to cancel, 1 upon pi dx upon 2 minus cos 2x. Got it? Santosh asked this. Santosh asked this, ma'am, when this 1 plus e power sin x went. So this was the answer. Okay. All right. Now we have another question which was asked in JEE Advanced 2014. Okay. All right. JEE Advanced 2014. Are we ready for it? Let's go. Let's go. Okay. Again, not a very difficult question. It's just that you will master calculus if you attend the complete lecture. Okay. So this question says you have a small function f. Okay, this function is continuous in 0 to 2. Okay, perfect. Small f. Now, and is differentiable in 0 to 2 with f of 0 is equals to 1. So, first statement of this question is talking about function small f, which is a function which is defined from 0 to 2, continuous and differentiable in this interval with f of 0 is equals to 1. First half of the question is decoded. Correct? Now, if I go ahead and talk about capital Fx, capital Fx, capital Fx is this. Can anybody tell me by looking at this, which one theorem comes into your mind in the chat box? Yes, KS Dinesh, yes, definitely. This question, this integral reminds us of Newton-Leibniz Theorem. Okay, why, ma'am? Why? How come that Dinesh is able to decode that Newton-Leibniz theorem? Because whenever you see that integration is there and power are variable, can you see the power is variable? Integration variable is different and power variable is different. That means this whole question will be done by Newton-Leibniz theorem. I think so many of you are agreeing on it. How to apply Newton's Leibniz theorem? I'll show you. First of all, we'll apply Newton's Leibniz theorem. Then after that, one more thing is given, which is f dash x equals to f dash x. F of 2 is what they are asking. I don't think the question is very difficult. JEE Advanced 2014. Come on. We are going to solve it right here. Differentiated. F dash x is equal to 0 to x square. Now differentiating. Left hand side, so you have differentiated. How to differentiate right hand side? See, integration is already there, so you just don't have to integrate. You don't have to differentiate because both integration and derivative will cancel each other. So what we are going to do is x square you are replace t by x square. That's it. So okay, ma'am. F of root x square. F of root x square is x. Now upper limit will be differentiated in the multiplication. Upper limit was x square, so you have to differentiate the upper limit, minus 0, f of 0. You have to put lower limit in this and lower limit will be differentiated. So anyway, it is going to be 0. So your f dash x is equals to 2x f of x. But as per the question, if you carefully observe, f dash x is also f dash x. So now this will help you. This thing will help you. This thing will help you. So whenever you see f dash upon f, if you are able to calculate f dash x upon f, that means your function of x is decoded. This is a very popular thing used in many questions. F dash upon f. Tell me, from here f dash upon f is 2x, correct? Now what you're going to do is you're going to integrate with respect to dx. So ma'am, okay, this integration is x square. What about this? Plus c. What about this? Ma'am, what about this? This is nothing but if you put f dash x, fx as t, then this whole thing will become dt. So integral dt by t is log of t, log of f of x is this. You've got your function, and also f of 0 is 1, correct or not? F of 0 is given as 1. So put x equals to 0, you get function f of 0 is equals to 1. So this is 0, 0 plus c, so constant term is also 0. So fx is equals to e power x square. Can you see? Fx from here is equals to e power x square, correct? Yes, yes, yes. Okay, all right. Now what they are asking, f of 2 is something that they are asking. So f of 2 ke liye I will solve it right here. Okay. See, f of capital Fx is nothing but integration 0 se x square, correct? And now we are having what? F of root t. So f of x is e power x square, no? F of root x will be what? E power root x whole square. So e power x, e power t. So basically this is e power t dt. So f of capital Fx is going to be, integrate this. So ma'am, e power x, e power t, sorry. E power t ka integration, and the upper and lower limits are 0 x square. So f of x is e power x square minus e power 0. This is your fx. Now f of 2, can anybody tell me? E power 2 ka square 4 minus 1. E power 4 minus 1 is sitting in the option B. Yes, yes, yes. Pradeep, perfect. Kishan, perfect. Okay, clear? And for all of those who have not liked the session, what are you doing, guys? Like it right away. Do not miss it. Okay? Chalo. So what do you think? JEE Advanced 2019, what do you think? Good? Question was good or not? Good enough? Now a similar question, can you see? Similar question. Same question was asked in JEE Main. This is the question I was talking about. Remember? E power sin x wala question. Similar question was asked in JEE Main 2025. Let me write. This is JEE Main 2025. So for all of those who are asking about second attempt, April attempt, look at this question, huh? Look at this question. Okay. Minus pi by 2 to plus pi by 2 x square. So I have already told you if this is your integration, then I will be equals to 1 by 2. You have to take half and you have to remove 1 plus e power x. So minus pi by 2 x square cos x dx. By using shortcut, I have removed this denominator. Similar thing, King's rule, and add. If you're going to add, you will get this only. So I'm skipping that step, right? And then now, x square cos x is an even function. Are you getting it or not? This is an even function. So this is 1 by 2 twice of 0 to pi by 2 x square cos x dx. 2 cancel, correct? So now integration I is equals to 0 to pi by 2 x square cos x. Okay. Obviously this question can be done using by parts, but what I will do is I am going to apply shortcut. Shortcut to integrate x power n into any trigonometric function. How to integrate? So x square cos x. Integration of x square cos x will be x square. X square will be, see, x square will be differentiated, cos x will be integrated. Okay. So x square cos x. Always think x square will be copied as it is. Cos x will be integrated right away. So you are going to get sin x. This is your plus sign. Now same thing you're going to do in minus sign. X square will be differentiated 2x. Sin x will be integrated this time. So integration of sin x is minus cos x. Okay, ma'am, correct. Now plus x square ka 2x, 2x ka you have 2x, 2x ka differentiation 2. And now see, you started with cos x, cos x integration was sin x, sin x integration was minus cos x. Now minus cos x integration is going to be minus sin x, and this is how. So minus plus, sorry, plus minus plus, and this is going to be 0 to pi by 2. Put the shortcut. Pi by 2 will be pi square by 4. Okay. Then pi by 2 right here will be pi, and if you put pi by 2, this is 0. Okay. Pi by 2 we are putting now, so this is 0. And pi by 2, if you put it over here, minus 2, upper limit. Minus lower limit, now you put 0, this is gone, you put 0, this is gone, you put 0, this is gone. So 0 pe to 0 aega. Pi square by 4, the correct answer will be what? Correct answer will be pi square by 4 minus 2, done. With the help of amazing short trick. Amazing. Can you see this short trick which was used in JEE Advanced 2016? By the way, by far, JEE Advanced 2016 is the most toughest examination. Okay. And this question, 2 ninja techniques we have used in this question. 2 ninja techniques. Two ninja techniques we have used in this question. First technique, remove 1 plus e power x right away and divide by 2. So this is it. Then we have used one property, that minus pi by 2 to 2 becomes 0 to pi by 2 if the function is even. Now x power n into cos x. How to integrate this? So we have, because if you apply by parts, trust me, it is going to take more time. Yes or no in the chat box. If you apply Eilert rule, it is going to take more time. So what we have done is, we have used a ninja technique to solve this integration in just one line, and you are done and dusted. Okay. Now, I don't know how many of you, yes Dinesh Kumar, I will do that. Okay. At least if not in one video, what I can do is, I can start making a playlist of all ninja techniques. Okay. One video, one technique. One video, sometimes 2 techniques. So I'll collect all the techniques in one place. Okay. All right. Now this question, have you seen this question somewhere? Have you seen this question somewhere? Anyone in the chat box? I to get deja vu. JEE Advanced 2015 question was asked in JEE Main 2025. Same question. Copy paste they have done. Whose shift was this question come in? In the comment section, please let me know. JEE Main 2025, January attempt. Correct? Okay. Now, fx is given as this. They are talking about 2 things. Now, understand the options. That the correct expression are multiple correct. Multiple options are correct. Understand, first of all, they are talking about x fx integration 0 to pi by 4, x fx integration 0 to pi by 4. So, my thing is A and C are asking us to calculate. First thing you have to calculate is x fx integration 0 to pi by 4. B option and D option, both are talking about integration 0 to pi by 4, just fx dx. Okay. All right. Yes. So now let us understand this fx. So what I am going to do is, we are going to just rearrange this fx right away. Fx will be what? So what I can clearly see that I can take something common from the first 2 brackets and from the second 2 bracket. 7, okay, 7 tan square x is equals to, now tan power, 6x. 7 tan power 6x, if I have taken common, 1 plus tan square x is right here. Minus 3 tan square x, if you have taken common, so this is 1 plus tan square x. Yes or no? Correct. 1 plus tan square. So fx is equals to 1 plus tan square x is sec square x, and you are having 7 tan power 6x minus 3 tan square x. This is your f of x. Correct? Now, first thing, like option C and, option B and D. Option B and D. We need to calculate option B and D. 0 to 1. Pi by 4. 0 to pi by 4. 7 tan power 6x minus 3 tan square x sec square x dx. Correct? Now you have to put tan x equals to t. If you put tan x equals to t, your upper and lower limit will become 0 to 1. So this is 7t power 6 minus 3t square, and this is your dt. And now if you integrate this, this is t power 7 minus t power 3, 0 to 1. And if you solve it, you are going to get a 0. T power 7 minus t cube, you are going to get 0. 0, 0, 0, 0. Option B is absolutely correct. That means, and D is incorrect. Okay, are you getting my point? Okay. So this is the first thing. Now x fx. Fx is right here, correct? Now what we have to calculate is x fx. So x sec square x, 7 tan power 6x minus 3 tan square x. And this is 0 to pi by 4 again, and this is your integration which you are looking for. Perfect. Okay. If you convert this, what will happen? Can anybody tell me, ma'am? I is equals to 0 to 1. This is your x. No, we cannot convert it right away. What we can do is we can apply King's property and add. Apply King's property and add. Okay. Don't do that. Don't do this. Put tan x equals to t. So I will be what? This is 0 to 1. X will become tan inverse t. Okay, ma'am. Then this is dt. And this is 7t power 6 minus 3t square. Correct? Tan inverse t and 7t power 6 minus 3t square. By parts. We are going to apply by parts. Okay? IITJEE rule now we are going to apply. So IITJEE. Inverse trigonometric function, first function, this is your second function. How to apply by parts rule? Tell me. I is equals to, now, first function constant, tan inverse t as it is. Integration of second function. So, if you integrate this, you are going to get t power 7 minus t cube. 0 to 1 is the upper and lower limit minus integration of derivative of first function and integration of second, and this is with respect to dt 0, 1. Now understand one thing, if you put upper limit, so 1 minus 1 0, lower limit 0 minus 0 0. So this I is equals to negative. Now understand I equals to minus 1 upon 1 plus t square integration of, this is 0 to 1. And this is t cube, if you take common, this is t power 4 minus 1 dt. Now t power 4 minus 1 again, if you just split this, you are going to get t square plus 1. Can you see t square plus 1 will get cancelled out? So this is t cube and this is t square minus 1 and this is your I and this is 0 to 1 dt. T power 5 minus t cube and integration 0 to 1 dt. So this is t power 6 by 6 minus t power 4 by 4 and this is 0 to 1. And now if you put 1 by 4 minus 1 by 6 minus 1 by 4, 1 by 6 minus 1 by 4, 6 4s are 24 and minus 2, so minus 1 by 12. Is it correct? Minus 1 by 12. Sorry, negative sign was already there, correct? Negative. So this is negative and this is also negative. plus 1 by 12 is the correct answer. Okay, so this question is having plus 1 by 12 is the correct answer. Option A. A and B both are correct. So this question is having A and B both are correct. Have a look. Let me know. Hi Rohit, how are you? Hi Adi. All right. Okay. So make sure that you're liking the session, and after the video is done, comment on the session below. Okay. Answer sheet we are expecting within a day or two. We are also ready for it. Once the answer sheet is released, we have a surprise session for you for all three subjects: physics, chemistry and mathematics. Yes, Satvik, I have corrected it. Good question. Yes, I also feel. And the same question, by the way, JEE Advanced 2015 question was there in JEE Main 2015. And now we are having one question which was asked in JEE Advanced 2019. Okay, let me check whether it is a, yes, this is the last question of the day. Last question of the day which we are going to do. See, this question is from the topic limit of a sum as a definite integration. So let me just tell you, limit of sum as definite integration. Let me tell you what I am trying to say. Suppose you are having this format, limit n tend to infinity, 1 by n, sigma f of r upon n, r is equals to 0 to n. This format can directly be converted into a definite integration. This is the way you solve this sigma and all. Sigma will be replaced by integration. R by n will be replaced by x. 1 by n will be replaced by dx. Now, r by n I have told you is replaced by x. So, if you put r is equals to 0, n is already infinity. 0 by infinity. So, lower limit you will get if you put r is equals to 0. So, 0 by infinity is going to be 0. So, x equals to 0 is going to be your lower limit. What about the upper limit? So, you put r equals to n. If you put r equals to n, n by n x, so upper limit. So, this is how you convert summation into definite integration. So, summation is right there. Limit of summation is definite integration. Limit of summation as definite integration. This is a topic which they have deleted from JEE Main. In 2024, they have deleted, but still sometimes they ask. They don't care about what is deleted, what is not. That is one thing. And yes, so now we are going to decode this, correct? Decode. Let's do this. So first thing which I understand is, see, this is not a very simple question, not a very basic question. Simple is there, but basic is not there. So I can clearly see that one summation is going on in numerator, another summation is going on in denominator. So numerator is a different question, denominator is a different question. This limit, so what we are going to do is limit. I am going to write limit n tend to infinity, and I am going to write 1 plus 2 power 1 by 3 plus and all the way up to n power 1 by 3. Correct? This is your numerator upon. Denominator mein limit again n tend to infinity and n power 1 by 3. Can you see this is n power 7 by 3. 7 by 3 is nothing but 1 by 3 plus 2. Correct? 7 by 3 is what? 1 by 3 plus 2. So this thing is n power 1 by 3. So this n power 1 by 3 I am going to divide. See, this is your what? This thing is n square and n power 1 by 3. Correct? So I want this n power 1 by 3 to get divided over here. So n power 1 by 3 I am going to divide it over here. And n square I am going to keep it right here. And from here, can you see I am just writing an plus 1 whole square plus an plus 2 whole square and all the way up to 1 upon an plus n whole square. Step by step we are going to proceed. Okay. Now can you understand that this is limit n tend to infinity? This is actually what? Tell me. This is 1 by n, then 2 by n power 1 by 3. 3 by n power 1 by 3. So this is actually r by n power 1 by 3. Correct? where r is varying from r is equals to 1 to n, correct? Whole upon. Now the term for you have denominator. So can you see that an plus 1 whole square? What I want is n to come out. It is not a tough question. You will understand this is not at all a tough question. If you know the concept, this is the easiest question of the lot. Okay. 2026 batch के लिए yesterday I made a video के edits. I hope that you have filled that form. I am reaching out to students personally के edits. So do fill that form and I am going to reach out to you personally. Okay, for 2026. Okay, so now n square I am going to take it out. Take n square out. If you take n square out, no, then n square will get cancelled out. So limit n tend to infinity. N square is out, so this n square will be out. If you take this n, see, if you take n out of this bracket, na, outside it will become n square. So this n will be out. This is 1 upon n. N will be out, 2 by n. N will be out, n by n. Correct? And n square will be gone because n square is taken common. So this is what it is, understand. 1 upon a plus 1 by n, a plus 2 by n, a plus n by n, so a plus r by n whole square. Sigma is right there, r starts from 1 to n. Okay, now understand, if I just tell you that sigma function of r by n is there, but can you see this 1 by n should always be there. 1 by n is not available over here, neither here. So I am going to multiply 1 by n over here and here so that it will compensate. I can do both things in numerator and denominator. Okay, so now this is going to become integration of, this is r by n will be replaced by x, correct or not? So x power 1 by 3 dx, this is 0 to 1 upon, what about this again, 0 to 1 a plus x whole square dx. This thing is your integration, which is given as 54. Numerator integration different, denominator differentiation integration different, is given as 54. So x power 1 by 3 will become x power 4 by 3 upon 4 by 3, 0 and 1 being your upper and lower limit upon. What will be the integration of, this is actually 1 upon, sorry, this is 1 by, dx by. Okay, so dx upon a plus x whole square. So integration of 1 upon a plus x whole square will become minus 1 upon a plus x, correct? And this is your integration, upper and lower limit 0 and 1. This value will become 54. Solve it right away. So this is 3 by 4. And what about this? This is negative of a plus x. So if you put 1, a plus 1, okay? So this is a plus 1. If you put 0, you are going to get minus a. Sorry. This is minus 3 by 4 upon. Now this minus of. So now if you put upper limit, you are going to get minus a plus. If you are going to put lower limit, minus 1 by a. Plus 1 by a. Correct? Okay. And the negative sign will be, that's it. This is gone. So 3 by 4 is equals to 54. Now solve it. Now solve it. See, 3 ones are 3, 3 ones are 3, 3 8s are 24. Correct? So this is 18 into 4. So 1 upon a minus 1 upon a plus 1 upon, this is, okay. So this is 4 times is equals to 1 by 18. Correct. Solve it, solve it, solve it. What will be the value of a? Possible values of a. Okay. Now if you solve it, a square plus a, and this is a plus 1 minus a is equals to what? 1 upon 18 into 4. Correct. So this is a square plus a is equals to 72. So a is equals to 8 comma minus 9. If you solve this quadratic, 8 comma minus 9. So 8 comma minus 9, option C and option D both are correct. Okay, both are correct. Ma'am, why you converted into integral? Simple limit after taking limit common. Mahesh, what are you trying to say? This is the clear, see, understand, this question is a disguise question. Disguise means that this question is an imposter question. This is not a limits question, trust me. Okay, whenever you see limit n tend to infinity and you can see a summation, that means the concept which we are going to use in this question is limit of sum as definite integration. So you have to convert your question in this particular format, and once you are done with that, then you have to do necessary transition. Summation will get converted into integration, and this is what your syllabus is. This is what your topic is. Okay. So now we are done with this particular session of mathematics, which was very much focused session on JEE Advanced Integral Calculus. So this session was all about integral calculus. Okay, we are going to do more questions on integral calculus. Do not worry about that. It's just that now I would like to tell you about something. This is your session, right? Okay, let me tell you one thing about JEE Advanced serious batch, and I'm talking about the serious batch. So if you can see, okay, if you can see that link is given in the description box. This Eklavya batch, hold on, this is very bright, you can't see, right? Now I think everybody is able to see. Description box mein Eklavya batch link for JEE Advanced is written. JEE Eklavya is right here. Master teachers with 10 plus years of teaching experience are going to teach in this particular batch. You can see that who all are teaching in Eklavya batch right here. Okay, and the price for Eklavya batch you can clearly see. What are the features? That obviously very few students will be there. Okay, very limited batch size, no need to say, because very few students will be preparing for JEE Advanced 2025. Periodic discussions. See, we are very serious about those students who have cleared JEE main cutoff or are expecting to clear JEE main cutoff. So now we are very serious that everybody should clear JEE Advanced as per their potential. Okay, so this is mock test will be there, assistance will be provided for state examinations just in your Eklavya batch. Okay, so counseling sessions will also be there, and view course plan. If you do, so you will realize that this is 4 months batch, crash batch, 14,000 for 4 months. But if you want pro, okay, the features are a little bit different in pro. Printed study material will be delivered in pro, but here no printed material will be delivered. That is why you can see the additional cost, and the cost is not at all very significant. It's just the additional cost for printed material. Okay, so yes, you can see the features. Code is already applicable, offer is already applicable. These are the specific dedicated team for JEE Advanced are there. See the qualification of the teachers, and these teachers are teaching for JEE Advanced and getting the results also. JEE Advanced toppers producing team we are having, in-house team. So batch schedule you can clearly see after this. So there will be timetable, and latest batch 2nd February it has started. So if not, you've not applied, not enrolled, so do it right away. Okay, all right, this is the most important news for all those JEE Advanced aspirants who are serious about JEE Advanced preparation. Okay, all right, so I think we are done with today's session. We are going to meet in next session super soon, and stay tuned with the channel. Do subscribe to this channel. This is me, your Ninja Ma'am, signing off.